All right, folks, I'm going to attempt to go over the homework from last night, and if you have any questions, you can always ask a neighbor, but I'm going to go over every problem in great detail. If you had some of these down, that's great. If you didn't have some of them down, then you can kind of fast forward to the parts that you struggled with. Again, all this is on my website, but I wanted to give a verbal explanation for every problem that you did, just so that you can have something to reference there. If you just looked at my work on the website, you're like, I still don't know what's going on. So we had from page 204, we have numbers 18 and 19 and 22 and 23. So I'll attempt to show you what to do there on those. It says some distance are best measured indirectly, and we'll talk more about this later on this year as well. A geometry class indirectly measures the distance across the sinkhole. The distance they measured are shown in the diagram. Explain how to use their measurements to find the distance across the sinkhole. Okay. Now, what I want you to see as we look at these two triangles up here is that the two triangles are going to be congruent to each other. Okay. And so as I look at the vertical angles, if I mark those down congruent, vertical angles congruent, this side corresponds with this side, that one would be with this one. So we have congruent triangles by side angle side. So what's the measure of the distance across the sinkhole? Well, it's going to be 26.5 yards because the two triangles are going to be congruent to each other. Okay. So again, 26.5 is what I'd be looking for there on that one. See if I can scroll down. No, can't. All right. Looking at the next problem there, number 19. Oh my goodness, a flow proof. Holy cow, it's so many steps. I don't know if I can do it. All right, let's take a look at this. A through H. Here's what I'm going to do before I even get going on anything else. I'm going to put down the given. Here's my given. There's one. A terrible G. And here's the other one. Okay. Now, as we look at the given, it says that line L is perpendicular to AB. Okay. Well, perpendicular, we've been talking about, means that they form right angles. So for part B right here, I'm going to put down definition of perpendicular. Okay, that's what led me to that understanding there. From there, we know that those two angles, ACP and BCP, have to be the same because they're both right angles, and all right angles are congruent. So for letter C, again, I'm putting down all right angles are going to be congruent. Okay. For letter D, we're told that line L bisects AB. Well, that cuts that segment in half, so we have two congruent segments. So I know that AC is going to be congruent to BC. Some of you may have been inclined to put down given because they're marked like that. I will never mark them. The book is trying to help you out. The reason AC is congruent to BC isn't because it's given, it's because of the definition of bisects. Okay? F, PC is congruent to PC. Hope no one got that one wrong. It's a reflexive property. Okay? And if I go ahead and mark the reflexive property there, it wasn't so good. Let's try that again. Okay. That's going to be side, angle, side. Again, because these are both right angles here. And they're congruent to each other. So side, angle, side for G. And then how do I know PA is congruent to PB? It's because of CPCTC. Yes. Okay. Now we also had numbers 22 and 23. So if I go, let's go ahead and clear that off. Go down to 22 and 23 here. Okay. In the exercises 21 and 22, name two triangles you would prove congruent in order to use CPCTC. Tell how you would show them to be congruent. Okay. You can go ahead and do a two-column proof here with this one. It wouldn't be too hard to do that. But here's what I would do for the given. That'd be step number 1. Okay. And then JK and PQ. Obviously, there's only two sets of triangles within this picture here to actually go ahead and write out. But what I would do from that point is I would probably go ahead and show step number 2, angle KMJ is congruent to angle QMP because all vertical angles are congruent. Okay? And then from there, I would have to go back to the given because there's nothing else from the diagram that really helps me out. And I would say, okay, lines are parallel. There's a reason why they're parallel. Well, the reason is because the alternate interior angles are going to have to be congruent. So for step number 3, I would put down either that angle J equals angle P or angle Q is equal to angle K. Okay? So I'll go ahead and mark those two. I'm going to say angle Q is congruent to angle K in the third step. And I'll probably say something like, if lines are parallel, because that's what we're starting with, then alternate interior angles are congruent. That's going to be my justification for step number 3. Okay? From there, I can go ahead and say that those triangles are congruent. So I'm going to say triangle KMJ is congruent to triangle QMP by angle side. Okay. After that, I then want to ask myself, what would have to be true in order for me to bisect segment JP? Well, in order for me to bisect segment JP, this segment here would have to be congruent to that segment there. Well, we already know that's true because the triangles are congruent and those parts correspond. So I'm going to then say, what is this, step number 5, I believe, that JM is congruent to MP by CP CTC. Okay, those parts correspond, so they have to be congruent because the triangles are already congruent. CP CTC. For step number 6, I would say that JM is congruent, I'm sorry, I said that wrong. Step number 6, I would say KQ bisects JP, and the reason is going to be definition of bisects, which means to cut in half or to have 2 equal parts. So, yeah, those 2 are equal, therefore they're cut in half. Okay? So that would be proof number 22. Again, you can see that on my website or you can go back and listen to that. Hopefully that made sense. And then the last one, proof number 23, we want to organize these. It says the reasons given in this proof are congruent, but they are listed incorrectly. Or I'm sorry, I said it wrong, didn't I? Congruent. The reasons given in this proof are correct, but they are listed incorrectly. List them in the correct order. Okay. Well, I know that B is going to have to go first because that's the given. So I'm going to put B first. I'll just put it off to the side over here. Number 1 is going to be B. Okay. Number 2, BD bisects ABC. Oh, that's the given as well. So technically, you could have B or E for number 1 and E or B for number 2. Either way would be acceptable. Both are given. Okay. Now, how do we know that angle 1 is going to be congruent to angle 2? Well, if BD bisects angle ABC, so again, we are cutting in half this angle. So this angle up here is being cut in half by that segment right there. What would have to be true? Well, these 2 angles here and here would have to be the same measure. So I'm going to say definition of bisects or angle bisector. So D would be the next one. Okay. For step number 4, BD is congruent to BD. Please tell me everyone got that one right. Letter C, reflexive property. Okay. I should probably mark that with 2 congruency marks there. Okay. And then from there, I know that ABD and CBD will be congruent. Well, how is that? Well, it's going to be by letter F, by angle side. Okay, and I think you can see that up there in that picture. The last one, would I then know that AB will be congruent to CB? The reason is because of CP, CTC. So number 6 is going to be letter A. Okay, those are corresponding parts of those congruent triangles. All right, now, the next one that we had to do or look at is page 213. We had 12 and then 21 to 24. So looking at number 12, here's what I see in number 12. With these 2 angles being congruent, I know that the sides opposite have to be the same measure. So I'm going to put down here that y is going to be 7. Okay, so that was really simple. It's an isosceles triangle. Base angles are congruent, sides opposite are congruent. How do I find x? Well, you can go ahead and take 180, the triangle, minus the 244 degrees. Okay. And from there, 88 from 180 gives you 92 degrees for x. Okay, so hopefully we got that right. And then we had 21 to 24 from this page. Let me just make sure that was right. 21 to 24? Yep, okay. So 21 to 24, if we look at those, love isosceles triangles. I think we're trying to find the angles here, right? Yep, find the value of x. Okay, so here's what I would look at when I look at this problem. I know that with these two sides being congruent, that the angles opposite have to be the same measure. Okay, so that's going to be 65 there. These two angles are vertical, so they have to be the same measure. And then with these two angles or sides being congruent, the angles opposite, just like in the previous one, the angles opposite have to be congruent. So that's going to be 65 as well. So this angle right here is going to be 180 minus 65 minus 65, which is going to be 50 degrees there. Okay. Now something I want you to think through with me real quickly in number 21 is this. Are those two triangles congruent to each other? And the answer is no. I think you can see the one on the left is smaller than the one on the right. But what would they be? And they're going to be similar to each other. It's a smaller version, same shape, but smaller version of the original triangle there on the right. Okay. All right. For number 22, here's what I see. Again, I have an isosceles triangle here. This angle here has to be the same measure as that angle there. Okay, so this is 70 degrees right there. Well, if that whole angle is 90, I know that this one right here is going to be 20 degrees. Okay. Well, again, I have an isosceles triangle over here, so this angle here is going to be the same measure as that angle there. Okay, so this is going to be 20 degrees there. Okay. So from there, x degrees right here, well, I can go ahead and take 180 minus 20 minus 20, and that will give me x. 180 minus 40 is 140. And again, like I've stressed all year, does that angle look like a 140-degree angle? Well, it's a pretty obtuse angle, so I'm going to say yes. Okay. All right, now, if memory serves me correct, number 23 is one that usually gives students some difficulty. If you're able to get it, that's awesome. But I'm going to go ahead and mark out that this side length is 2x minus 5. Okay? We know that they're congruent to the other side, so 2x minus 5. Perimeter is 20. So I'm going to go ahead and do x plus 2x minus 5 plus 2x minus 5, and that will equal 20. Okay? And so from there, if we go ahead and simplify this, we have 5x minus 10 equals 20. I'm going to go ahead and add 10 to both sides and then divide through by 5. Okay? And if I plug that in, this would be 6. This would be 12 minus 5, 7. And this would be 12 minus 5, 7. 14 plus 6, that's 20. We're good to go. Okay? So, again, those problems are 21 to 24. Let's do one last one, 24. Again, I'm trying to show you guys how I would solve these if you're not sure. I'm always drawing these arrows in to show the two angles that are congruent. So this angle is congruent to this one. How do I find the x degrees? Well, I'm going to go ahead and take 180 minus 60 minus 60, which is going to be a 60-degree angle again. So what do we know about that triangle? It's an equiangular and equilateral triangle, right? Okay. Now this angle right here is going to be 180 minus 60. And that's going to be 120. All right. So from there, I know that this angle here and this angle here have to be the same. And so technically, this is probably the easiest way to solve it. Y plus y, the two y's, plus the 120-degree angle is equal to 180 degrees. If I go ahead and solve for y, 2y would equal 60, and then divide through by 2. Each of those angles are going to be the same degree. Okay? All right, let's see here. I like it. That's good. Let's go on to the last section of homework here. We also had page 219, 5 to 7 and 9. 219, 5 to 7 and 9. 5 to 7 reads this. What additional information do you need to prove the triangle is congruent by a hypotenuse leg? Well, number 5, I hope that you guys registered the fact that we need a right angle. They look like right triangles, but we don't know. So I would write down something like this. Angle T and angle Q have to be proven to be a right angle, okay? Or just the triangles need to be right triangles, okay? For number 6, we know that RV is congruent to itself by the reflexive property. We already have right triangles, which makes RV a pair of hypotenuses, opposite of the right angle. So from there, we would either have to prove either XV would be congruent to VT. Sorry, guys. VT. Okay, we'd have to prove that. Or we'd have to prove the other leg's congruent. XR is congruent to RT. Either way, that's going to help us prove the triangle's congruent by a hypotenuse leg. For number 7, we have triangle tri and triangle IR. We want to prove them congruent. So I'm going to go ahead and say the reflexive property with the hypotenuses there. And so just like number 6, we have to prove a pair of legs congruent. That's all it's missing. And so I'm going to say TY would need to be proven congruent to RE, or TR would need to be proven congruent to YE. Okay, either one of those is all you need to prove the triangle's congruent. Okay? All right, for the last problem here, number 9, we want to, it's the same type of problem. Oh, let's see if that works. There we go. What additional information do you need to prove the triangle is congruent by the hypotenuse leg theorem? BDC and FEA. Well, I'm going to go ahead and say if that's a right angle, we already know that that one's a right angle. Likewise here. Okay, so we know we have a pair of right angles. We know we have a pair of legs congruent. What's missing? We need a pair of hypotenuses congruent. And the only hypotenuses within those two triangles would be BC and AF. So we would need to prove BC congruent to AF in order to use the hypotenuse leg theorem. Okay? So again, hopefully all that made sense to you. When you're done, make sure you show the sub your homework, and you can move on with today's lesson. Thank you.